Hi, welcome to Linear Measurement in 2023. First, let's start talking about metric measurements. Metric is what's used in science. Metric is measured in centimeters, millimeters, meters, kilometers, and centimeters are divided into millimeters. There are 10 millimeters in 1 centimeter, and decibels are incredibly important. The top of this ruler is in metric. Standard measurements are in what we use in the United States. It is inches and feet and miles. Inches are divided into fractions, and fractions are incredibly important. The top of this ruler is in standard. When you look at a metric ruler, metric scale, you count the tick marks between 0 and 1 to determine your scale. This ruler is accurate to 0.1 centimeter or 1 millimeter because there are 10 tick marks between the 0 and the 1. In a standard ruler, notice that the measurement lines are all different sizes. See how the tick marks are different sizes? When you look at a standard ruler, you're looking at how many tick marks there are, how many total tick marks there are, and that will tell you the accuracy of the ruler. That's also the denominator of your fraction. This ruler is accurate to 1/16 of an inch because there are 16 tick marks between 0 and 1. So using this metric measurement, how long is the red line? Well, notice that we're in centimeters, and notice that there are 10 tick marks, so we're going to the 0.1 centimeter. So this would be 3 is our whole centimeter. 0.1, 0.2, this would be 3.2 centimeters. How long is that green line? If we're looking at standard measurement, we would need to count the number of tick marks. So the biggest tick mark is a half, the next biggest is a fourth, the next biggest is a eighth, and the next biggest is a 16th, and the very smallest would be a 32nd. So this ruler is accurate to 1/32 of an inch. But notice our measure goes to the second longest, and that was the 16th. So if we were going to count, we would start with 7, because that's our nearest inch lower than where we are. So we have 7, and then count all the little tick marks all the way up, and that would be 7 and 26/32, but that can be reduced to 13/16 of an inch. The green line is 7 and 13/16 inches. Now let's look at some motion diagrams. Motion diagram is where an object is at any given time. And here you're given 3 examples. Let's focus on runner 1. In this class, we will default to each mark being made each second. So if we line up a tape measure for runner 1, and we would gather the following data. Notice that we are measuring in metric and we are using centimeters. So if we focus on the runner's back foot, we would gather the data that at 0 time, he's at 0 seconds, 0 meters, 0 centimeters. At 1 second, he's at 1.9 centimeters. At 2 seconds, he's at 3.8 centimeters, and so on, gathering this data. Now, when you go to graph that data, you can use either a Google Sheet or it can be done by hand. But every graph needs 4 elements. The nice thing about a Google Sheet is it'll do it for you. But it needs 4 elements. It needs the axis labels in units, what is being graphed, the scales, what the graph is going to count by, the data points, and a line if you're requested to draw a line that fits the data, and a title, IV versus DV. IV is the independent variable, DV is the dependent variable. So let's look at a Google Sheet. If I open this Google Sheet, I can actually paste my data that I'd copied previously, and I can use a Google Sheet to graph that data. Here are the steps. 1, highlight all of your data. And if you just pasted it from the table that you created, it's going to just be highlighted already. But highlight your data from the titles all the way down through the end of your data. And this data had 6 data points. Then you go to Insert, a Chart, and if it's not already a beautiful little scatter chart, you want a scatter chart. You go to Chart Type and you pick Scatter. And if it doesn't show up, you scroll down and you get the scatter chart. Believe it or not, that's it. Notice that it already has the title. It has a scale of what we're counting by. It has the axis labels with the units, and it has all of my data points. Google will do it for you. I want to shrink it down just a little bit so I can get a better picture, a better snapshot, if you will. And I'm going to actually take a snapshot of this and paste it into my assignment. And it would look like this. The last thing we need to talk about is conversions. Dimensional analysis, being able to convert from one unit to another. You need to be able to convert feet into meters, inches into centimeters, etc. These will be a form of single measurements, not a series of measurements. So on your formula sheet, you need the following abbreviations, right? Because you need to know what you're reading in a word problem. Inches is IN, feet is FT, miles is MI, kilometers is KM, meters is M, centimeters is CM, millimeters is MM. And for your time conversions or your time units and abbreviations, these are the units. Seconds is an SEC. Be careful using just an S because sometimes they look too much like fives. Minutes is MIN and hours is HR. Also on your formula sheet, you need the conversions. 1 inch is equal to 2.54 centimeters. 1 meter is 100 centimeters. 1 centimeter is 10 millimeters. 1 kilometer is 1,000 meters. 1 foot is 12 inches. 1 mile is 5,280 feet. 1 minute is 60 seconds, and 1 hour is 60 minutes. So this is an example of dimensional analysis. If we had done a measurement activity where we had a total distance of 5 feet, 6 3/4 inches, what would that be in centimeters? Well, first we need to get our feet into inches. So we use a little table that shows 5 feet, and it needs to be converted into inches. In order to do that, you have to dimensionally analyze, which means you got to get rid of the feet. You multiply by 12 to get 60 inches. Then we need to change our 6 3/4 into a decimal, which would just be 6.75, and add. So we have a total of 60.75 inches, and we need that in centimeters. So just like we canceled the feet, top to bottom, like a fraction, we're going to cancel the inches, and we're going to multiply 66.75 inches times 2.54 centimeters to get a total of 169.545 centimeters. These are the things you're doing in class today. Thanks for watching.